Welcome to our first session of summer school. What I'm going to be doing over these next three sessions is really pointing you in the direction more to advance your CAD skills. Okay, so when we get back to school after the summer break, we're going to be starting our modeling, we're going to be starting our development. So being able to quickly model any of your designs on CAD is really important. We've done some CAD skills earlier on in the year, and I'm going to be using this time during home learning to help you develop them even further, teaching you a few more skills that you perhaps didn't do before. So what we're going to start off with now is how to do some 3D drawing. Okay, so most of us are able to draw in 2D on CAD, but actually being able to draw in 3D and then change that sketch into a 3D shape is really important. Okay, so what we're going to do is I'm just going to make a simple sort of bedside table, or it could be you could alter the measurements and change this into a coffee table or anything. Now, if I were to say to you, how would you make this? Most of us would sort of know where to start. It's nothing particularly complicated. It's all rectangles and things like that. And the logical way to do it would be to start a new design and draw all of the pieces individually. So I would probably start by pushing R on my keyboard and drawing a rectangle, the size that I wanted it to be, okay, and then extruding that rectangle out, okay, to be one of the pipes. Okay, and then selecting this surface and doing the same sort of thing. So clicking on R, drawing another rectangle, and then clicking on E and extruding that out. Okay, and you can do that, and that's one way of doing things. But as with Fusion, like we've been teaching you in the past, there are lots of different ways of doing it, and sometimes there's a right way, sometimes there's a wrong way, sometimes it doesn't matter. But there's certainly a quicker way of doing this, and I want to show you that today. So being able to draw like we've just done in 2D is one skill, but I want to show you how to draw in 3D. So I'm going to point you in a direction. I was going to record the video myself, but actually I found a really good one online, and if you haven't found this guy, I really recommend him. He's called Kevin Kennedy, and he produces a Facebook page, a YouTube channel. I think he's on Facebook as well, for how to learn Fusion in 30 days. Okay, so he's done a video every week, and this is his video here. So if you go onto YouTube, how to sketch in 3D on Fusion 360, it will show you how to do that. So I'm going to take you through that video now, and hopefully by the end of it, you will have learned some new skills that will be really helpful to you actually in developing these things. So this is one of a series of free videos that I'm going to be doing during summer school to help you do your CAD skills with a view of when we get back to school, being proficient on CAD, a little bit, learn some new skills that perhaps you haven't learned at school, and also being able to model your designs quite quickly in 3D.
In this video, we'll look at the key differences between 2D and 3D sketching. We'll then build this C-shaped side table using the latest 3D sketch enhancements in Fusion 360. The March 2020 update brought significant changes to Fusion 360's 3D sketch feature. Beforehand, it was cumbersome and very unintuitive. Now you had to use the move command to manipulate sketch objects. For most users, it was hard to even figure out how 3D sketching should fit in the typical workflow. Before we take a look at how to 3D sketch with the new update, let's look at the key differences between 2D and 3D sketching. With a 2D sketch, we constrain sketch geometry to the plane used to create the sketch. We're able to create a new 2D sketch on any of the origin planes, construction planes, or any planar face of a model. 2D sketches can originate anywhere in 3D space. However, they're considered 2D sketches because we're constrained to the 2 coordinates of our sketch plane. With a 3D sketch, Fusion 360 removes that planar restriction, allowing us to create the sketch geometry anywhere in 3D space. This means we can start with a typical 2D sketch and we can continue the geometry onto other 2D planes, keeping the sketch geometry one continuous piece. Knowing when to use a 3D sketch instead of a 2D sketch can make all the difference. In short, you'll want to use a 3D sketch to create a path for tubing, sweeps, lofts, or surface edges when the design continues to multiple planes. Contrary, 2D sketches should be used for common features like extrude and revolve. Looking at this image, these are 4 great examples of items that would benefit from a 3D sketch. Now, the shape of an axe is very unique because it tapers in multiple directions. Using a 3D sketch, we can minimize the number of sketches and other features needed to recreate the shape. The second object, the C-shaped table, is what we'll build in the remainder of this video. If you look at the frame of the table, you'll see that it's one continuous path of square tubing that's welded together. Because the shape is one continuous path, we can use a 3D sketch feature to sketch out the path, followed by using the pipe command. Bike handlebars are another common use case, as they're often bent in multiple directions, which is something that we can't easily recreate with a flat 2D sketch. The fourth object is a shower caddy. Now, similar to the furniture example, we can use 3D sketching to our advantage to recreate the outer contour, as well as the continuous shape of the baskets. We could then use the pipe command or even the sweep command to create the 3D bodies, ultimately saving us time while having to use fewer features. Let's now get started with the example, which should make the concept of 3D sketching easier to understand. To start, you'll want to make sure that you're in the Design workspace and under the Solid tab. We'll first create Sketch and select the XY origin plane. Now I'm choosing this bottom plane as I'm going to start with the bottom of the table frame. At this point, we need to turn on the 3D Sketch feature. The easiest way to turn it on is to simply check the 3D Sketch option in the Sketch palette. Before starting with a line, I'll also hit the home icon next to the view cube. You'll almost always need to look at the sketch from a perspective to understand what's going on with the 3D sketch. Pay close attention to what happens in the middle of the screen as I activate the line command in the toolbar. You'll see that additional sketch planes appeared, along with some rotation manipulators and some extra axis lines. These all represent the new enhancements to the 3D sketch feature. With the latest update, we're now able to continue sketching directly onto another sketch plane. We can rotate the plane in real time, or we can extend the axis out to help us better manage the geometry. To start, I'll select the center origin and drag my mouse over to the right. At this point, we're just creating a 2D sketch while viewing it in 3D. For the dimension, I'll type out 45 centimeters. I'll then make sure it snaps into the green y-axis at 90 degrees. Now that we have this first section of the base, we can head straight up to create the vertical part of the frame, resulting in a 3D sketch. To do this, we'll move our mouse over to the Z-axis where it snaps to the axis. You'll see that we're now able to continue with this line in the third dimension. I'll type out 60 centimeters for the height. This time, we'll need to select the Z-axis, again making sure it snaps in at 90 degrees. If we rotate the model, we'll see that we now have the start of a 3D sketch. Take note of how the sketch plane and 3D sketch features move. They'll always move to the last sketch entity. We now need to head back to the left to create the first piece of the top of the frame and to finish off the first C shape. One challenge with 3D sketches is the fact that we still want to make sure that we fully constrain our sketches when possible. We also want to make sure that we use the least amount of dimensions as possible, so it's easier for us to have design intent, keeping the model predictable. With that in mind, we don't want to add a dimension for this line, as we want it to match the first line, which includes the length. Instead, we'll simply click on the green y-axis to place the line. We'll then use a constraint to force the line lengths to be the same. Hitting the escape key will not only clear out the line command, but it will remove the 3D sketch options, making it easier to add constraints. We can then select the horizontal/vertical constraint in the toolbar. Selecting the endpoint of our last line and the starting point of our first line will force this vertical relation. This will ensure this top line will remain the same length as our first without having to use a dimension. To continue, we can reactivate the line command and select the endpoint where we left off. We now need to create the width of the table frame. For the width, I'll follow the red x-axis and I'll type out a dimension of 25 centimeters. Once again, we'll make sure to click where it snaps in at 90 degrees, or in this case, along the x-axis. For the next line, we'll head back to the right. Once again, we'll want to place the line without a dimension value so we can force the length with the constraint. However, I do want to point out that the 3D Sketch feature also has a lot of great reference lines that help us place geometry. Notice all of the lines that appear as I reference other points of the sketch. I'll select the equal constraint in the toolbar. Select the last line and the opposite line. This will force the lines to remain equal in size. We could have used an equal constraint for the previous line. However, I wanted to show you that there are often several ways to achieve the same result. We can now reactivate the line command and continue the frame by drawing a line straight down. This time, I'll use the reference geometry to make sure the line snaps in at 60 centimeters while remaining vertical. We can then finish off the frame by creating the last two lines, making sure they snap in at 90 degrees. Once they're both complete, hit the escape key to clear the line command. You'll see the last two lines are blue, which means they're not fully constrained. To fix this, we have to think a little bit different since we're working with a 3D sketch. Our shape is also somewhat of a unique case because we're essentially mirroring the C shape while connecting it together. By constraining this back line, we're freezing these last two lines in place since everything else is already constrained. I'll apply the equal constraint to the back two lines. Notice how the front two lines turn black as well, and our 3D sketch is now fully constrained. We can double check that it's fully constrained by looking for the lock icon next to the sketch name. This means we can now update the length, width, or height of the table without skewing our desired shape of the 3D sketch. We're now ready to turn this 3D sketch into a 3D body. First, however, I want to point out one more thing with 3D sketches. And that is the fact that 3D sketches result in only one sketch feature in the parametric timeline. Contrary, if we were to create the same table shape with three different two-dimensional sketches, then we would have three separate sketch features in the timeline. At this point, we can switch over to the Solid tab, where we'll find the pipe command in the Create dropdown. If you're not familiar, the pipe command lets us create a solid that follows a selected path. As you'll see, the difference from the pipe command and the sweep command is the fact that we can define several details of the pipe. Once activated, we simply need to select the path. I should also point out that with 3D sketches, you can apply sketch fillets to any of the corners, giving you more control over the shape. You'll also find on this tutorial's resource page, I've listed out all of the sketch tools that work with this 3D sketch feature. Within the pipe dialog, we can first change the section shape to a square to represent our square tubing. Now the distance option lets you define how far along the pipe should follow the path. We can leave that set to 1 and 0, which makes it follow 100% of the path. For the section size, I'll type out 2.5 centimeters, which represents the width of our square tubing. One advantage of the pipe command over the sweep command is that we can easily make pipes hollow. If we check the hollow option, we're presented with the section thickness, which means you're defining the thickness of the material, not the width of the hole. For this, I'll type out 2 millimeters. I'll then click OK to confirm the pipe command. Using the section analysis tool, we can check to confirm that the pipe is hollow on the inside. At this point, we're done with the frame of the table. Hopefully, this beginner 3D sketching tutorial helps you better understand a few of the advantages to using 3D sketching. If you would like me to cover more advanced 3D sketching concepts, then let me know by dropping a comment down below this video. To finish off the tutorial, we can create a new component for the top surface. Now watch what happens when I select Create Sketch and click on the top of the surface of the frame. Many of you will expect Fusion 360 to automatically reorient the model, so we're looking directly at it. However, when the 3D Sketch feature is enabled, this will override the Auto Look at Sketch feature. I'll disable the 3D Sketch feature and I'll finish the sketch, and I'll also delete it. Watch what happens as I now create a new sketch. As expected, the model reorients so we can create a 2D sketch while looking directly at it. I'll simply use the 2-point rectangle command to create the top surface. I'll then use the extrude command to create a thickness of 2 centimeters. Of course, you can take the model even further by adding fillets, appearances, and other details. To summarize, I want to remind you that the advantage of 3D sketching is the ability to be more efficient with certain shapes and paths. 3D sketching is also really powerful when used in conjunction with surface modeling. Again, I've listed that and several other use cases on this tutorial's resource page.
Okay, so there was a video showing you exactly how the Kevin Kennedy manufactures this table. As I said to you, what I was hoping you would get from that is how to use the pipe command and how to draw a path first of all, and then make it into a 3D shape. Now, some of the benefits of doing that, there's obviously benefits and negatives. Obviously, the benefits are things like you can make it hollow inside quite quickly, you can shell it out. The negatives are obviously if you wanted to show the joints of that product and you wanted the metal legs perhaps to be made up of different parts and show how they would go together, you would have to split the object after all. But there's just a different way there of actually constructing. And what I'd like you to do is perhaps go through that video and pause it. I've also put a link, if you don't want to watch it straight on the screen as you've just had it with my screen recording there, I've put the link to the actual video in the assignment as well. But you can pause it if it was going too quickly, slow it down. What I liked about his videos is how much detail he goes in about understanding the processes and why. What I'd like you to try and do is I'd like you to try just do a print screen for me and then upload your final table to the assignment. Now, you don't have to keep it just to that basic table. If you wanted to, you could add a drawer underneath, or maybe try and experiment to make yours a little bit different than his. Maybe add something else on top, or add some drawers going out to the side or something. So, create your design a little bit differently. But today's first summer school session is about 3D sketching to try and just develop your skills a little bit further. I'm going to be doing 2 more sessions later on. Again, just developing different CAD skills along the way to develop your skills. I hope you found this useful, and I look forward to seeing your responses to this.